let's start with machine learning. Let's stop with psychology. For a little while, we can continue after, of course. So today I want to discuss the Mixtral of Experts paper. And before we start, I have some questions for the audience. Who knows what a transformer architecture is? Everybody. Well. Okay. Who knows what a mixture of experts is? Okay, we all know the contents of the paper. We can stop here. Thank you for the attending. Well, if you all know, then what are you interested in discussing? I mean, this is guys in this paper just applied.
Well, I generally understand the idea of mixture of experts, and I'm curious what they did, particularly in this paper, what result they get, how it works in this particular case, and in practice, in concretics. So we'll see.
Okay. And you?
My major is it's my way of learning. I not understand something from the first time that I read, and then I just revisit something concept. I understand it better and better. Deeper details. That's why I do this.
So is mixture of experts the same as an ensemble, or is it different?
No, okay, let's discuss what exactly they call a mixture of experts in this paper. So basically the whole idea of this paper is they present their new model, and because it is a cool thing to do, they publish a paper to describe the amazing results this model achieves. Despite this, the methods they use are not new in any way, at least to my knowledge. The mixture of experts is an old method, and the transformers are old as well. And it has been rumored that ChatGPT, at least from the version 3.5 and above, also uses mixture of experts under the hood. They just don't announce it. And the main selling point of these guys is that they open source their model under the Apache license. They open source their weights, and that's why they recommend using them instead of closed models. But let's move on to the description of what they do.
I'm sorry.
Yes.
Could you please zoom in a little bit?
So
Could you please zoom in a little bit?
sure.
Yeah.
If I no.
As a gesture,
Pinch.
or yeah.
Pinch out.
Okay. So when in neural network you usually have in feed-forward neural network you usually have a layer where you have an input vector. You multiply it by some matrix, apply some activation function, and you have an output vector. When you want to do a mixture of experts approach, you can, instead of a simple matrix, have a number of them and several really small model which decides which of those matrices should be applied to our input.
So the router is not a simple classifier.
In case, can you repeat this?
In this case, router is a simple classifier.
Yes, exactly, yes. However, you might want to use more than one expert. In this case, you just pick not the best one, but the two best one, or however many you want.
You just softmax it, yeah.
Yes, exactly. Of course, you can do it not on the level of a single layer of the neural network. Instead of different matrices to multiply, you can route your inputs to different neural networks, which can be more complex than a single layer of a feed-forward network. And in the end, if you use multiple experts, you combine the outputs in number. You can do it in a number of different ways. You can basically summarize them. You can concatenate them and then transform to your target dimension by another feed-forward layer, whatever. So the main advantage of this approach is that during inference, you don't need to load and process all the parameters of your neural network, only those layers and those experts through which your router network routed your inputs. So in the transformer architecture, in the transformer block of the transformer architecture, we have two layers, first an attention layer, and then a feed-forward network after it, which applies to each token. They apply mixture of experts to the second part of the transformer block, to the small feed-forward network. So basically, before we had a signal feed-forward network in each layer of transformers. Now we have, in this case, 8, and a small router which decides which layer we should load for this particular token.
Okay, this is something new for me, because I think before that they have like a full okay, you have routing for some expert and it goes through whole transformer architecture with this particular expert, but you correctly said that they just skip it and go to the feed-forward layer in the end. But where they go through this previous part, so where is these steps go?
If I understand your question correctly, you thought that in a classical mixture of experts approach, an expert is a whole new different transformer model.
Yeah.
Okay. Here they don't do this. They let's know what happens. So we have our inputs. They go through a number of transformer layers where they have feed-forward network in regular transformer and attention. They replace this box, this feed-forward network, with a mixture of experts for each transformer layer. So they have whatever number of layers. So they have 32 small mixture of experts networks.
So it's one attention layer and multiple these variants of the feed-forward layers.
Yes.
And they this
and here they for each token they go through the router network, small router network, which decides which expert to send this particular token.
But it's very interesting how these feed-forward layers, just simple MLBs as I know, how do they make an expertise in there?
So you're asking why this works?
Yeah.
Well, what we want to achieve here is to reduce the number of parameters we need to invoke during the inference. And in theory, this approach reduces the number of parameters.
For sure.
But the question as to whether the quality would be the same of the network without this router, just with the plain feed-forward network, or better or worse, is up to experiment. So they did the experiment, and here we can see the results. The mixture of experts model on all benchmarks works better than the regular transformer. Why? They don't have a good explanation. Besides that, we gave more parameters during training data, and the model have a bigger number of hidden parameters of not active parameters. While the active parameters count is the same, but because overall number of parameters is bigger, the capabilities of the model is bigger. But why? We don't know, because it's machine learning. We don't have anything to do other than other than do experiments. They try to do some analysis of on what is going on with different what's going on in the mixture of experts part. For example, here they plot the distribution of how frequently each expert is invoked on different layers, and you can see the distribution is quite uniform. Even on different subjects, the distribution is still the same. So we can't really say that experts are trained to do different subjects. No, maybe they then wonder if different experts responsible for different parts of speech, for example, whether they have some, I don't know, grammatical meaning behind them, so they do these kind of illustrations where they color the text in the color corresponding to the experts that was picked by the model to process the token. And as you can see, some logic is present, yes, for example, in the layers most closely located to the inputs and to the outputs of the model, where the tokens are most closely correlated to the embeddings of the tokens. For example, in the code, you can see that white spaces in the beginning are processed by the same expert. However, it's not the behavior is not this clear in the middle of the transformer.
So it's not that some experts are the experts in the starting of the sentence and some experts in the middle, and that's not so correlated.
Yes, it's hard to find out how exactly it works inside, but well, it works.
So they named the paper the mixture of experts, but that's not mean the real experts actually.
Yeah, it's just
the additional feed-forward layers that
which may not be activated on each run.
Okay, got it.
So that's it.
Very straightforward.
And of course, they have the marketing table saying that they're better than everything, and results.
So they're not better than everybody.
Yes.
So Cloud One is, I don't know, they are open source or not?
No.
Not?
And they are relatively small. I mean, 7 billion active parameters is not that much.
Yeah, but as I remember, they're a bit bigger. Yeah, the network has 70 billions, but in the inference they use just 7.
Yeah.
Did you try it actually?
Did I try?
Yeah.
No. I don't have the views, or I did not have any reason to try it.
Do you know which kind of GPU machine you need for this particular?
I guess.
Well, it's like the same as Llama.
Yes, it's the same as Llama. It's like
Llama is different.
Which one? 7.
So
the Llama 7.
okay.
Well, I think at least one of the points was that you can load these 7 billion parameters into kind of consumer grade GPU.
Yeah, but you can't actually run it with one GPU because you still need to hold those other parameters in those non-active parameters in memory in case you need them for the fast processing.
Well, I think you can have them in main memory and load and unload onto GPU.
Well, in case
Yeah,
you do this, you can run
Yeah, that's gonna
the
be
same GPU.
somewhat slow, but probably still workable.
About benchmarks, do they have only benches, or do they have human ratings? because like I have the intuition that benchmark hacking is pretty common.
I believe they have some human regulations.
Because remember, MLU is one of the main one here.
But I don't actually know.
All right.
Here, are they there on this open LLM leaderboard on the Hugging Face?
They do show a screenshot from there.
Yeah, from this
Well,
arena.
We can access the leaderboard and see
If
like where are they in the rating right now? No?
okay, I guess we can do it for fun.
Link below.
It's interesting. Is it like they are not the best one right now in terms of like open source?
In the browser.
Yep, here they are.
Besides, there you have your benchmarks like MMO. You whatever. Too small for me. Who's there?
Well, that's it. No more questions.
Did you expect do you have a notion of do you expect research in this direction to continue, and if yes, how?
To which direction? Is the direction of applying mixture of experts to large language models? Well, I guess it will become the mainstream technique. However,
When did they publish?
quite recently,
Previous year.
I believe it's 23.
Yeah,
It
definitely.
was like an ITS big conference, and it started the it they published.
I can't use my sorry. Let me do it here.
I think it's like 3-4 months ago.
Yeah, something like this.
Yeah, it's a pretty recent paper.
Yeah, January.
Not pretty.
Yeah, but
Ah,
8th January.
it's this month.
Yeah.
What's Mars?
No, but the announcement of this Mixtral was out there last year. Definitely.
So there was a question about what is sparse.
Why it's sparse?
Why it's sparse?
Just not mixture, just a sparse mixture. Do they like?
I believe it is called sparse because you don't need to compute to process all the parameters on each pass through the network, because I can imagine an architecture where you pass the inputs through all the experts and decide which outputs you want to keep instead of deciding which experts to use preemptively. So the one where you pass through all experts regardless would be called a dense mixture of experts, and the one where you choose experts before executing them is a sparse one.
One thing that I want to add there, I watched like the last time course about the transformers, and it was some papers there in this course that tell exactly that in the feed-forward rate layers they have multiple objectives, and one of the objectives of feed-forward layer is like a memory. And they have proof that some kind of a memory of a transformer is in a T4 layers, and it makes sense actually there if it's like a memory inside memory of the architecture. If you train differently these memory cells, yeah, it's like you choose exact memory, and as an expert, so from this point of view, it makes sense. But I don't know if they have a link to this paper that I meant. Actually, that's would be interesting.
Okay. That's a nice interpretation, which kind of explains why.
It's my guess, you know. It's